Okay, this is lab 5 where you choose your own adventure, and I decided to do a collision, so I looked at the collision of two golf balls. The purpose of my lab was to model a collision of a rolling golf ball and a stationary golf ball. And from there, test the conservation of momentum using both balls and the earth as the system. So the experiment was pretty successful. My model didn't work for the first part before the collision. I tried to fix it for a long time, but I haven't taken CS, so I was having a hard time, and I didn't know what else to do. So here are the equations that I used. So for this lab, I decided to use the average velocity of the ball before the collision. So the way that I did it, it was rolling down a slope. So that's why I'm using average velocities here. And let's see, here we can watch. So I used slow motion so I could have more points to track. So here's my ball going. It's really slow. Basically, this is just what happens, and then here you go until it hits the other ball. So I used those points to find the average velocities, and here's my code. I used the net force being the tangent times the ball's mass because it was on the slope, as you can see here. It's kind of hard to tell, but this is sloped. So I found the force on the ball and used that to find the acceleration, and then plugged that in for the first part. And then for the second part, there's no net force on it, so in the x direction, because I'm only looking at the x direction for this lab. So I just changed it to the average velocity that I found from this. So when you run it, for some reason it doesn't show up for the first part, but it should for the second. Well, hold on. So sorry, this is taking a really long time. So for whatever reason, that's the only part it shows. I couldn't figure out how to make it work for the first part. So but yeah, so these are the averages I found. And when I calculated the change in momentum, it was 0.05. So that's pretty close to 0. The reason it's not exactly 0 is probably due to ignoring the contact force of first the slope and then just the floor. I tried to use like a surface that didn't have a lot of friction, but possibly could have moved the camera, especially since it was on a pretty small scale. Small movements of the camera would have mattered a lot. And I ignored movement in the y direction. I tried to use only the parts where it was really only going in the x direction. But the floor might have been slanted a little bit, which would have changed the findings. And I was also using averages, so that could have been a reason that it wasn't exactly perfect, because the balls may not have been moving at constant acceleration or obviously constant velocity. So yeah, that's it.